Hi guys, I hope that everything went well with the last lesson. I hope you were able to view it and that you could understand it and that you could get mostly all of the problems in that problem set that I assigned from the last time. And if not, I'm going to see you on Tuesday, so we'll go over any questions you have then. And I have been, you know, I'm pretty much like, I don't know, after I do these videos, I'm sort of drained because I'm still sick. So I'm not like looking at my emails and stuff too much, but you know, if you have a question that's really pressing, you can send it through EDSB, and if I happen to look at it, then of course I'll answer it, and if not, then I'll address it on Tuesday. But today we're going to go into section 4.2, which is on page 203, and we're going to differentiate exponential functions. This is really easy, but they can be tricky sometimes. So I'm going to go over a few examples. It's pretty much a memorization game, all right? So the exponential functions are functions of the form b to the x. So you have some numerical base raised to a varying power, like maybe, you know, 3 to the x or 5 to the x, something like that, okay? You also have e to the x, right? Which is e to the x. Nothing much to say about that at the moment. So the rule is, well, you know, suppose I have a function like this, 3 to the x, and I need the derivative of that thing. Well, I don't want to go through the whole, you know, limit as h approaches 0, because that gets pretty tedious very quickly. So what you'll do is you'll remember a rule. We say that the derivative with respect to x of an exponential function is equal to the natural log of the base times the function itself, times b to the x. So for example, if I wanted you to find the derivative of 3 to the x, you would say the derivative with respect to x of 3 to the x is equal to ln of the base times 3 to the x. So ln 3 is just a number, okay? I don't know what it is. I'd have to put it in my calculator, but it's some crazy little number. Ella, stop. Sorry, my dog's going a little bit crazy at the moment. All right, so anyway, regardless of what that number is, you're just going to follow this rule. So this is the rule for the derivative when you have a numerical base raised to a varying power. Now, you're going to love the derivative with respect to x of e to the x, because the derivative of e to the x is e to the x itself. It's the same function. So that's a really nice one, right? Really super nice. So let's do some examples just to make sure you have some, you know, to look at. I've got the book here, and what I'm going to do is the some of the even problems, and some of the more trickier ones. It's not that they're hard, it's just, you know, some things you got to look out for, okay? So for example, f of x equals e squared minus 7e to the x. So now I have more than one term here, okay? So I have to take the derivative term by term, just like we would with a polynomial. And I would say f prime of x is equal to, well, what's the derivative of e squared? This is the trick. E squared is a number. It's 2.71 times 2.71, whatever that turns out to be. So we know that the derivative of a constant is 0, right? So that's done. Here I have the derivative of negative 7 e to the x. So let me just put the 0 there. All right, so now I have the derivative of 7 times e to the x. Well, 7 is a constant multiple. I could write that as 7 times the derivative with respect to x of this exponential function. Well, what's the derivative of e to the x? It's e to the x. So the answer for this is negative 7e to the x. Done. Cute, isn't it? Okay, number 4. So this is example number, or problem number 4 from the book. It says f of x equals 2x to the 4th minus 5e to the x. I want the derivative. Again, I have more than one term, so I'm going to take this piece by piece. The derivative here, this is not an exponential function. This is, I can use power rule with this, right? So this would be 8x cubed minus what? 5 e to the x. Done. Another form you might see this in is like number 6. Y is equal to 5 times 3 to the x. Now, hopefully you learned in algebra to never, ever, 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 never multiply a numerical base by a constant. You never touch this base. Never change it, never multiply, divide, nothing, right? So this is the number 5 times 3 to the x. It's times this exponential function, 3 to the x. So this is just a constant multiple. So really, what you're taking the derivative of is you've got 5 times the derivative with respect to x of this thing, which becomes 5 times ln 3 times 3 to the x, and you would leave it just like that. Nothing to clean up, don't try to combine it. These two, you know, I mean, I probably wouldn't write the dot, I'd just say 5 ln 3 times 3 to the x, but this whole thing right here is just some number. Okay, so just leave it like that and you'll get it right every time. Let's see, here's another one. Number 8, s of t is equal to 2.7 to the t minus t to the 5th. So the derivative, now this is exponential, this is a numerical base raised to a varying power, so I know that this is, ln 2.7, right, times 2.7 to the t, and then this one minus this one here, I'm going to use power rule, 5t to the 4th. Guys with me on that? Here's another one that might be tricky at first, but once you see it, it will trick you no more. F of x equals e to the pi plus x to the pi. Well, e is a number and pi is a number, so this is just a number. So what's the derivative of a number? It's 0. This is not a number raised to a variable. This is a variable raised to a number. So guess what? Power rule, right? I bring the exponent down and subtract 1 from it. So the final answer is just pi x to the pi minus 1. Cute. Let's see. Get another piece of paper here. Number 12. So number 12, we have f of x equals ln 6 times 6 to the x. Once again, this is just some number, so you can pull it out. You can think of it when you take the derivative as a constant multiple times the derivative with respect to x of this little exponential function here. Well, the constant multiple stays the same. We multiply that by ln 6 times 6 to the x. When I take the derivative of that, I get this here, right? And then you could write this, I mean, I don't know how best is writing it in the book, but you could write this as ln 6 squared times 6 to the x if you wanted to. Or you could leave it like that and IB would still give you credit for it. Now, here's another form you may see, and so I want to jog your memory with some algebra. F of x is equal to the 7 to the x plus 1. You cannot use the power rule on this because this is not just 7 to some number or, you know, to some weird number. And this is not 7 to the x. So you have to rewrite this using rules of exponents from algebra. This is equal to 7 to the x times 7 to the 1, or just 7, right? So remember, when the bases are the same, we can add the exponents. You keep the same base and add the exponents. So if I forgot about this for a second, I had two of the same bases, I would write the base and then write the exponent as x plus 1 because they're multiplied to each other. Okay, now I have something of the form. In fact, I'm going to write this with the 7 out front because multiplication is commutative. It doesn't matter where I position it, I'm still going to get the same answer. So I'm just bringing that constant to the front. Now I have a constant multiple, so the derivative of that is just going to be 7 times ln 7 times 7 to the x. Okay, cute stuff. One more, and then I'll let you do some practice. We have 16, which is f of x is equal to 1 over 2 to the x. So again, I have a numerical base raised to a power, a varying power, or a variable power. And so that means I'm going to need to use my little rule. So the derivative of this is going to be the natural log of 1/2 times 1/2 to the x. Capiche? That's it. So what you're going to do, the homework in this section, is you're going to do page 206, 1 through 17 odd. And you're going to find the derivatives. By the way, sorry if my paper's crooked. I just noticed it in my phone now that this videoing thing is not for me. But anyway, I hope that this helps. I hope that you'll be able to do all of these problems without really any struggle at all. Again, any questions that you have, we will discuss on Tuesday. So have a great weekend and go Big Red.